Welcome to UFON Electronics. Today we are going to explore one of the fundamental components in electronics, which is the capacitor. We'll dive into what capacitors are, how they work, and their applications. Let's get started. Firstly, what's a capacitor? A capacitor is an electrical component that stores energy in the form of an electric field. It's made up of two conductive plates separated by a dielectric material. When a voltage is applied across the plates, electric charge builds up, creating an electric field. The capacitor's ability to store charge is measured in farads, and it's represented by the symbol C in circuit diagrams. Now let's see how capacitors work. When a capacitor is connected to a power source, the plates become charged and an electric field is created. The capacitor stores energy in this electric field. When the power source is removed, the capacitor discharges, releasing the stored energy. This process is known as charging and discharging. Capacitors can store energy for a short period, making them useful in a wide range of electron applications. Now let's talk about capacitor calculations. The capacitance of a capacitor is calculated using the formula C equals Q over V, where C is the capacitance, Q is the charge, and V is the voltage. For example, if we have a capacitor with a capacitance of 4 microfarads and it's connected to a 12-volt battery, we can calculate the charge stored on the plate using the formula Q equals C times V. Plugging in the values, we get Q equals 4 times 10 raised to the power of -6 farad times 12 volts, which is equals to 48 microcoulombs. Now, there are several types of capacitors, each with its own characteristics and applications. Let's take a look at a few common types. First, we have the ceramic capacitors, the electrolytic capacitors, and then the film capacitors. The ceramic capacitors are small, inexpensive, and widely used in electronic circuits. The electrolytic capacitor, on the other hand, have a higher capacitance value and are often used in power supplies. Film capacitors are known for their high stability and are used in applications where precision is crucial. Capacitors have a wide range of applications in electronics. They are used in audio equipment to filter out unwanted frequencies, in power supplies to smooth out voltage ripples, and in timing circuits to control the frequency of oscillations. Capacitors are also used in energy storage systems such as capacitors, supercapacitors, which can store large amounts of energy. Let's take a look at some of the examples of capacitor applications in real world scenarios. When working with capacitors, it's essential to follow safety precautions. Capacitors can store energy even after the power source is removed, so it's crucial to discharge them properly before handling. Always check the voltage rating and polarity of capacitors before using them in a circuit. Additionally, be aware of the potential risk of electrical shock or capacitor failure. So that's it for today's tutorial on capacitors. We've covered the basics of what capacitors are, how they work, and their applications. We also discussed capacitor calculations and safety precautions. If you have any questions or need further clarification, please feel free to ask in the comment section. Don't forget to subscribe to UFON Electronics for more electronics tutorials and explanations. Thanks for watching. Bye for now.